Ever look up at the night sky and just feel small? I mean, totally overwhelmed by the sheer scale of it all? It's so easy to think that you need to be some kind of math genius to understand the cosmos. But what if I told you that's just not true? Drawing from the fantastic book, A Student's Guide to the Mathematics of Astronomy, we're going to unpack a simple but really powerful toolkit that'll have you thinking just like an astronomer. So let's jump in.
The universe operates on a scale that is, frankly, just ridiculous. We're talking about distances measured in quadrillions of miles, and masses with, 30 zeros after them. So the biggest challenge for any astronomer is, how on earth do you even start to measure that? How do you make any sense of something that's basically ungraspable?
Okay, let's bring this down to Earth for a second. Forget about stars and galaxies for a moment and just think about this simple question. 30 years. That's a number we can all get our heads around, right? But watch what happens when you break it down into a much smaller unit, like seconds. Take a guess. What do you think the number is?
Get this, it's almost a billion seconds. That's a massive number, and it comes from what feels like a pretty normal amount of time in a human life. And this just perfectly shows the problem. Even things we're familiar with can create numbers that are just way too big and clunky to really work with.
But here's the secret. Astronomers aren't sitting around plugging gigantic numbers into supercomputers all day. Nope. Instead, they rely on a handful of core mental tools that simplify the complex and make the colossal, well, comprehensible. And today, we're putting those exact tools right into your hands. So our first tool is the most fundamental one of all. I like to call it the cosmic translator. See, the universe speaks in all these different, kind of strange units: parsecs, light years, astronomical units. The job of the cosmic translator is to take that alien language and turn it into something that we can actually intuitively understand.
And honestly, this is where it gets super intuitive. Just think about it like converting money. If you're traveling and you see something costs, say, 500 rupees, that number is pretty meaningless until you convert it into a currency you use every day. Well, astronomers are doing the exact same thing, just with cosmic distances and weights. And the process itself is surprisingly easy. This is the foolproof method, right out of the book. First, you just find your exchange rate, your conversion factor. Then you write down the number you're starting with. And finally, and this is the key part, you multiply it by that factor written as a fraction, so that the old units on the top and bottom just cancel each other out. It totally eliminates any guesswork about whether you should be multiplying or dividing.
All right, let's try it. Proxima Centauri, our closest star neighbor, is 1.29 parsecs away. Now, a parsec, what does that even mean to most of us? It's just an abstract word. So let's fire up our cosmic translator tool and make some sense of it. And boom, when we run the numbers, we find out the distance is 4.21 light years. All of a sudden, that abstract number becomes a concept we can actually grab onto. It means the light we see from that star tonight, it actually started its journey to us over 4 years ago. Now that is the power of translation. All right, let's grab our next tool. This one builds right on top of the first. I call it the comparison engine. The secret here is that, a lot of the time, astronomers care less about the exact value of something and way more about how it compares to something else. Is this star bigger? Is that galaxy farther away? That's where ratios become your best friend. Okay, this slide shows the difference perfectly. On the left, you've got the absolute method. You calculate the first area, then you calculate the second area, then you divide them. It's a lot of steps. But the ratio method on the right, it's so much more elegant. It gets right to the heart of the matter by focusing on the relationship between a circle's area and its radius. Okay, let's put this comparison engine to the test. So if you take a sphere and you triple its radius, what happens to the volume? Now, your gut might tell you that it also triples, but the universe is a little sneakier than that. So the secret sauce is this proportionality relationship you see right here. A sphere's volume isn't just proportional to its radius, it's proportional to its radius cubed. And that tiny little 3 up there, oh, it changes everything. It creates this exponential explosion that our brains, which tend to think in straight lines, find really surprising. So when that radius triples, the volume doesn't just go up by 3, it goes up by 3 cubed. That's 3 times 3 times 3, which is 27. A small change in one dimension leads to a massive change in another. And that's the kind of powerful insight that ratios give you instantly.
And just like the source material says, this isn't just about doing math faster. It's about building a better mental map of the universe. Saying one star is 31 times farther away than another gives you a real intuitive sense of scale, way more than saying it's 4.4 quadrillion miles farther away.
Okay, on to our final tool. And this one is a real lifesaver because it lets us handle those truly mind-bendingly huge numbers. The number shrinker, or as you probably know it, scientific notation, is how astronomers keep from going crazy when they're dealing with numbers that would otherwise fill an entire page. I mean, just look at this thing. This is the mass of our sun in kilograms. It is a 2 followed by 30 zeros. Imagine trying to write that out every single time, or worse, trying to do math with it. Forget it. There has to be a better way.
And here is the beautiful, elegant solution. Scientific notation takes that monster number and breaks it into 3 simple parts. You've got the coefficient, which is 2, the base, which is always 10, and the exponent, 30, which just tells you how many zeros are hiding in there. That ridiculous number from before just becomes a neat, tidy 2 times 10 to the 30th. So much better.
But the real magic happens when you do math with these. If you want to multiply 2 huge numbers, you just multiply the little coefficients and add the exponents. To divide, you divide the coefficients and subtract the exponents. Look at the table here. Suddenly, what looked like an impossible calculation becomes simple arithmetic you could almost do in your head. It's incredibly efficient. So, there you have it. In just a few minutes, we've put together the fundamental toolkit that astronomers use to make sense of the entire universe. And it's not about being a math whiz, it's about having the right tools and knowing how to look at the problem. So let's quickly recap what's in your new toolkit. You've got the cosmic translator to turn things like parsecs into something that actually makes sense. You've got the comparison engine to help you understand the scale of things. And you have the number shrinker to tame those gigantic numbers with scientific notation. And here's the most important takeaway. You now have the same fundamental mathematical framework that professional astronomers rely on every single day. This lets you look at a big, complex cosmic problem and know exactly how to start, how to simplify it, and how to figure it out. So I'll just leave you with this thought. You now have the keys to a whole new way of seeing the universe. You can translate its weird languages, you can compare its giant parts, and you can handle its mind-boggling scale. So the only question left is, what cosmic mystery are you going to solve first?